Pointer is an interesting topic. A pointer is a data type. A pointer is simply an internal machine address. It stores someone else's memory address. So you can think of this data type called pointer that stores a memory address, which is in hexadecimal number. Let's say 0 times FA21, which is also an integer in decimal. So here's a couple of examples. The first one is a declaration of an integer. This one is just an integer. The second one is a declaration of a pointer. This declaration doesn't have anything other than integer start p. This start means this particular p is a pointer. You can also have start sitting next to integer space p. It doesn't matter how you write it. Now, because a is an integer, it takes an integer. Now, p stores someone else's memory address because p is a pointer. So the way to do that is you will have to use ampersand a. This ampersand signifies the address of a. So a is declared, which means there's a memory address associated with this. We can say a stores in this location. The memory address of a will be 0 times FA21. And that is the value of your p, 0 times FA21, by way of doing this. Now, in order to get that value, 0 times FA21, you have to dereference that pointer, which is that starts or extras before p. This extras cannot be attached to any integer. It has to be used in conjunction with the memory address or pointer. When you print this out, which is a digit, this will end up giving you an equivalent value of 0 times FA21 in decimal. Let's look at some fundamental pointer operations, such as pointer arithmetics. This is how we inline the declaration of various different variables. There's 3 of them: integer a, pointer this, pointer that. And this pointer points to an integer. So is that, which also points to an integer. Because this is a pointer, it can store the memory address of a. So this is just an example of how we can assign address of a declared variable to something else. But that something else must be a pointer. We can also assign a value to a variable to which a pointer points. So you can think of this entire pointer like this. A pointer itself has a memory address, 0, 5. For example, this. And this also has a value, which is someone else's memory address, 0 times 60F. And if you were to dereference this dereference means you're getting into the red area, which is the value section of that pointer. And that value section of pointer is now 4. So this one is no longer true. Instead, you'll have 4 sitting inside of the here. You can also assign pointer from one to the other. Remember, this is a pointer, so it's that. You can say, hey, the value of that pointer is now going to be the value of this. So you can swap pointers that way. Doing this is pretty dangerous because now that you have to keep track of where the original memory address is, because that is literally pointing to something that is in memory. And that something could have been dynamically allocated, which means there could be memory issues if you misuse that memory space. You can also create a new variable by using malloc. In C++, this malloc is new. So what malloc does is it returns the memory address or the allocated address, which is size of integer. Typically, these are 4 bytes on your computer. This 4 byte memory space could be here in red. This entire 4 byte memory address, let's say 0 times F2, is now assigned to this by way of this. So a couple things happened. One is the size of integer must be determined. 2, this malloc or new looks into the memory pool, looking for a suitable spot for your size of, which is 4 bytes. Once found, it declares that spot as taken and assign the memory address of that spot to this. That's what happens here. We'll look at pointer operations in the next video.